Let's discuss now our last problem in our topic rate problems in algebra. So this is the problem. In order to qualify for the next heat, the race car driver needs to average 60 miles per hour for 2 laps of a 1-mile race tracks. The driver only averaged 40 miles per hour on the first lap. What must the driver's average speed for the second lap in order to average 60 miles per hour for both lap? Okay, so that's the question. So if you look at this problem, there are so many terms here that if the student or anyone who reads this and don't understand some of the terms, that's one contributing factor na hindi ma-solve yung problem kasi you don't understand. For example, laps, what does laps means? We have race tracks, okay? Race car. So these are the terms that if the reader or the student don't understand this, it will make their mind more confused on how to solve this problem. But again, the best approach here is to make a table. Then estimate your table 2 by 4, 3 by 4, 4 by 4. So it's up to you. Just look at the problem. Okay? So anything that you can do in order for you to find ways on how to solve this problem, then you should do that. So this problem looks very difficult, but actually this is an easy problem. Okay, so let's try to solve this. So I will recommend to make a 4 by 4 table. Actually, it's not necessary, but as I mentioned in our other problems in this topic, that's very helpful to help us figure out on how to solve the problem. Okay, so let's start solving this by drawing our table. So I recommend to use 4 by 4 table, 4 rows and 4 columns. So these are the 4 columns. Then let's divide this into 4 rows. So these are the rows. And then let's write down the important items that we need. So we have the distance, then we have the rate, and we have the time. Okay, so let's read the problem once more. In order to qualify for the next heat, the race car driver needs to average 60 miles per hour for 2 laps. So let's write down what are the names mentioned here. There's no names mentioned except the word driver. Okay, then there's also a mention about first lap. And then we have second lap. Okay, so let's write here driver. Then we have the first lap. And we also have another driver, so same driver. Okay, then this is for the second lap. Then it mentioned about average. It says what must be the driver's average speed. Okay, so we cannot combine that in this part here, but we can write it here. So driver, still driver, then this is just right here average. Then write down what are the givens. So it says that in order to qualify for the next heat, the race car driver needs to average 60 miles per hour for 2 laps. So we have here a racetrack. The distance is 1 mile, no? one race track, 1 mile. So, and then it mentioned the driver only averaged 40 miles per hour on the first lap. So the first lap, its average speed or rate is 40 miles. So write down this, 40 miles per hour. Then the distance, 1 mile racetrack. So the distance is 1 mile. Or 1 mi, or you can write the whole or the full word mile. Okay, so first lap, average of 40 miles per hour. So the question is, what must be the driver's average speed for the second lap? So speed or the rate. So we need to solve for this. So this is what is asked in the problem. So the purpose here is to make the average or to comply the average required speed so that the average becomes 60. Okay? So the average for 2 laps must be 60 miles per hour. So for 2 laps, the total distance is 2 miles. So from here, you can solve for the time. So again, we have the formula that distance equal to rate times time. Alright, so talking about the average speed of the driver, so we can have here average speed or average rate. So they're just the same. So we can use this formula, distance equal to rate times time, or we can write this as rate times time equal to distance. So we have the distance here, we have the rate, then we can get the time, the average time. So from this formula, if you want to solve for the time, so let's divide r on both sides. So r, the numerator cancels with r, the denominator. Then we have t for the time. Then distance, 2 miles, substitute 2 miles or mi divided by the rate. Rate is 60 miles per hour. 60 miles per hour. So we have the miles cancels. So invert this. So the time is equal to divisible by 2, divisible by 2. So that is 1 over 30, and the unit here is in hour. So we have calculated the time here. The average time is 1 over 30 hour. On the first lap, we can also calculate the time. No? First lap. So again, we have distance equal to rate times time, or we can say rate times time equal to distance. Then solving for the time here, for the first lap, so divide both sides by r. So divide this by r, divide this by r also. So at the numerator, r at the denominator cancels out. So we have the time t equal to d over r. So the distance is 1 mile. This is 1 mile. So 1 mile divided by rate is 40 miles per hour. 40 miles per hour. So miles cancels out, numerator and denominator. So we have t equal to 1 over 40 r. So we have calculated our time here, 1 over 40 r. So actually, it's not necessary, but just to show you, while figuring out how to solve this problem, you can do this also. Actually, the equation that you need here is just this one. So it says that what must be the driver's average speed? Average speed or average rate for the second lap in order to average 60 miles per hour for both laps. So actually, the direct solution for this is something like this. We have the rate for the first lap, which is equal to 40 miles. Okay. Then plus the rate on the second lap, which we don't know yet, so we can let that be equal to R. And then average. So when we speak of average, so these are the two rates, right? Two rates or two speeds, average speed. So you have to add that one, then divide this by 2. So the average, the required average must be equal to 60. Okay, so actually you only need this one, but what I'm showing you here, just in case that you cannot figure out how to solve this problem, but while doing this, you will be led to this one. Now as you read the problem over and over again, and you can figure out how to solve this problem by understanding this part of the question, what must be the driver's average speed for the second lap in order to average 60 miles per hour for both laps. Okay, so we have here the equation. Actually, we're just looking for this value. So that is what is asked in the problem. What must be the driver's average speed for the second lap? So this is the average speed for the second lap. That's R. And this is the equation that we need. Okay, so this is an equation with fraction. So the rule in finding or solving the equation with fraction, multiply both sides of the equation by the less common denominator. In this case, there's only one denominator here, so we can multiply both sides by 2. Okay, so multiply this by 2. Our purpose here is to make our equation without fraction. So 2 at the numerator cancels out with the 2 at the denominator. So we also do the same on the other side. On the right side, we multiply this by 2 also. So the equation on the left becomes, or the expression on the left becomes 40 plus R equal to 2 times 60 is equal to 120. Okay, so I'll put it here. So 40 plus R equal to 120. So to solve for R, let's subtract both sides by 40. So subtract both sides by 40. So applying the technique that I was teaching you in the other videos. So 40, positive 40 cancels out with a negative 40. Then bring this down. So we have R equal to 120 minus 40 is equal to 80. Okay? So this is our answer. But what's the unit? So R must be in miles per hour. Okay? So therefore, the driver's average speed for the second lap in order to average 60 miles per hour or 60 mph for both laps therefore the driver's average speed for the second lap in order to average 60 miles per hour for both laps is 80 miles per hour. So this is our final answer. So you can check that one. So how to check? You just make use of this calculated time, and also you can use illustration. So if to illustrate this, so it's something like this, no? So for This is the total distance for 2 laps should be 2 miles. This can also help you figure out on how to solve this problem. So 2 miles. And to qualify, okay, so the driver should have an average for 2 laps of 60 miles per hour. Or in terms of time, so the time here must be as calculated, that is 1 over 30 hour. Then we're given that for the first lap, so this is 1 mile. Okay, so from here to this point, so this is 1 mile. And then the time spent here is 1 over 40 hour. Then there's a corresponding rate. There's a corresponding rate for this one, which is equal to 40 mph. So this is what we are asked for. So this is the rate on the second lap, assuming this is the first lap, distance covered for the first lap. And this is for the second lap. Okay, so you can make use of this illustration also to help you able to figure out how to get what is required in the problem. Alright, so I think that's all. If you have any more questions or you want some more clarification on this part, you just leave your comments below and I will explain you more details about this or the technique on how to solve this kind of problem. Thank you.